Okay, here we shall see about the applications of Ampere's circuital law. So the first application is to determine the magnetic field due to a straight conductor carrying current. Okay, so let us see how do we find out the magnetic field due to a straight conductor carrying current using this Ampere's circuital law. Okay, so for that we will consider this figure, okay, in which we have a straight conductor carrying a current I. As you know, this straight conductor will produce a magnetic field around itself. Let me consider any point P which is at a distance r from the conductor. Now, to find out how much is the magnetic field at this point due to this conductor carrying current I, then I will draw, a closed loop. I will draw a closed loop which is passing through this point P. Now my closed loop here, it is a circular loop that surrounds the current I. Okay. Alright. Now, again, over this point P, I will consider a small elemental length dl. And this small elemental length dl, it has got a direction, and its direction, it is directed in this way. Okay. Alright. Now, similarly, because at any point on the loop, the magnetic field, it is always tangent to the loop. So at this point P, if I consider that the strength of the magnetic field is B, then the directions of the magnetic field B in this case, it will be also acting along the same directions of dl. So here, the angle between B and dl will be 0 degree, which means theta is equals to 0 degree. So if that is the case, then by Ampere's circuital law, we know the line integral of magnetic field, that is integrations of B dot dl, is equals to mu naught times the total current enclosed by the loop. And my total current here, it is I. Or I can say this line integral B dot dl, it is equals to B dl cos theta. Okay. And since theta is 0 degree, so instead of theta I'll write cos 0. So this equation now will become just B dl and is equals to mu naught times the total current enclosed by the loop. Again, as I have already mentioned before, that this magnetic field, it is same at any point on the closed loop, right, which are at the same distance from the conductor. So in that case, this B, I'll take it out and I will integrate only dl. Now, integrations of dl, it means you are finding the total length of the loop. Now, the total length of this closed loop, it is the circumference of the loop. So, the circumference of the loop here, it is 2 pi r. And this is equals to mu naught I. Or just B is equals to mu naught I upon 2 pi r. Right? So this is my required equation about the magnetic field due to a straight conductor carrying a current I. So please, study well about this topic. This is very important, not just for your exam point of view, but this is actually important for your higher studies. You'll be needing this when you are going for BSc also. So please remember, how do we calculate the magnetic field due to a straight current carrying conductor by applying Ampere's second law. So this is how we find out the magnetic field. Alright? Okay.